everybody. Rich Green here with you, coming live from Sands Orlando 2026 with Josh Wright. Josh, thank you so much for joining me.
Thank you, Rich.
I know we're both busy, we're both teaching right now, but the whole world, not the whole world, there's a lot of people right now who are probably familiar with what has transpired, right? We're talking about Axios, NPM compromise that's going on. Josh, what can you share with us high level? Like what's happened? What are we looking at right now?
Here's the situation. The Axios package is an NPM package used for node development, and it is a very popular package. Some estimates indicate between 80 million and 100 million downloads per week. So it's used for web requests and managing web content. So really popular for lots of different packages, used from open source to commercial software, all over the place. Today is the 31st, and at just after midnight UTC tonight, a threat actor replaced the package with a new dependency. And that new dependency brought in another third-party package that affects Windows, Mac, and Linux systems and actually deploys a remote access trojan, starts scraping credentials and harvesting authentication tokens, cloud credentials, and other resources to try to give the threat actors additional access. Now, it took about 3 hours to figure out that this was happening. So from just about midnight UTC to just about 3 a.m., we saw this package being used, and we're still waiting on some early numbers. But if you look at 100 million downloads per week, that's like about 600,000 or so installs of this package. The dilemma we have with a lot of these kind of software supply chain problems is we know about it, we can get it shut off quickly, but the people that have been impacted by it now have a lot of incident response to do, and we won't really understand what the impact is until all of those 500,000 or so people do their incident response and find out what was compromised in their infrastructure. We know the threat actors are targeting GitHub credentials, personal access tokens, and a whole bunch of other information, so sometimes these supply chain attacks have a way of self-perpetuating themselves as well.
And really quick, I know for any of those that may have caught your talk you gave at RSAC, you talked about supply chain attacks, right? The vendors, supply chain. When we look at that, what is the concern there overall when we think about that? Because I think some people might just look, microscopically or internally to themselves, but I think it's far more expanding than that. Is that correct?
Yeah, it definitely is. The big problem we have with supply chain attacks is that it's a really rich opportunity for attackers. It's just too good to overlook. At RSAC, I mentioned Alan Paller, who was, of course, the founder of the SANS Institute. In 2015, he said, if organized crime isn't doing hacking, then they should be sued for malpractice, right? And I always love that quote. But I think we have a similar situation here. If you're a threat actor and you're not looking at supply chain compromise, then you're leaving a whole lot of opportunity on the table. Part of the problem with supply chain, and what I tried to cover in my RSAC panel talk, is we think about the software that we get. Maybe we get software from Microsoft or Intuit or third-party providers, and we're just used to saying, okay, this is my supplier, this is who I'm getting software from, and we have a trust relationship with that vendor. They're going to supply patches, they're going to help me maintain and keep my software secure. But the problem with supply chain is not that there's a vulnerability in Microsoft Stack or OpenClaw or whatever package that you're installing. It's a vulnerability in the library that OpenClaw is using. And maybe not even that. Maybe OpenClaw is using a library that uses a package that is vulnerable. And that extends significantly. At RSAC, just for an example, I talked about 7-Zip. Now, Igor Pavlov, the author of 7-Zip, it's a thankless job, right? When you're an open source developer, nobody says thank you, but everybody uses 7-Zip, right? And when you look at the 7-Zip software, it's really complex. There's lots of compression algorithms, there's all sorts of file type mechanisms, there's encryption support. When I started peeling back the onion on 7-Zip, I found 300 external software dependencies. Wow. And the risk is not that I'm installing 7-Zip, it's that when 7-Zip is made, it's pulling in software from all of these different sources, all these different repositories. That's the attack surface. Yeah. Same thing for the Axios issue here. Your software might not be using Axios directly, and maybe it's not something that your developers are using, But what about the library that they're using, or the library that that library is using? And it's turtles all the way down to try to figure out where the exposure is for this kind of an attack.
It really is that second, third, fourth, and in this case, fifth, sixth, seventh, eighth, order of effect, which is absolutely mind-blowing. And before we get too far, because I know some of our listeners might not exactly know what a package is, could you elaborate a little bit more on like what exactly a package is for those that might not know?
Definitely. So if you're a software developer and you're writing software, you have the option of writing everything from scratch.
Yeah.
That's costly. It takes a long time. And frankly, you might not do a good job, or I might not do as good of a job as somebody else that's already done some of those building blocks for me. So for example, if you're writing an application and you need to deal with an API endpoint to get data or report analytics or work with a Mongo database or whatever it is, you're not going to write all that code yourself. You're going to pull in a package. And that package is written by somebody else. Maybe it's from a trusted maintainer. Maybe it's from an untrusted maintainer, but you're going to pull it in all the same to relieve your developers of a lot of that effort. Modern software is built on the backs of everybody else, right? There's that classic XKCD where it's like Amazon, Google, like all Microsoft, all these big players, right? And way down here, there's a little block, and it's like a guy in Kentucky maintaining a package every other Sunday since 1992, right?
Yeah.
That's the package issue, right? We've built all this software, we've taken advantage of all this stuff, and not to say maliciously, not to say with ill intent, but this is how software was built. The dilemma is, what if those packages we rely on become insecure or expose us in any point along the way? In a nutshell, that's the supply chain risk.
Yeah, absolutely. And I'm pretty sure everybody that's watching now or that we've seen, I've seen and we have seen this more and more of these types of package compromise that are popping up across the span, and it's actually wild. And I know it's early in the process, and we don't want to go out there and start stating actualities or things like that. But like, what can you give us about we'll use IOCs or indicators of compromise. Like, what do we know a little bit deeper about like what's going on? Like, what does that look like for us?
Yeah. So for this compromise, I was talking with a bunch of students in class this morning, and they were all like, "Yeah, we get the call 2 a.m. and we're like trying to wearily figure out what's going on." But what we know is that anybody that's installed the Axios package between midnight UTC and around 3 a.m. UTC this morning got this malicious version, which pulled in this other package. The other package is called plain-crypto-js. It's interesting because the threat actor is not modifying the existing Axios software. They're just saying, you also need this. And when you do an NPM install and you bring in that package, it has to bring in the dependencies, and it brings in this other malicious package. That gives the attacker a lot of flexibility because they can change that plain crypto.js package version 4.2.1 as if there was a 1.0. It's just an arbitrary number, but they can control what's going on these remote systems for all of that time. It also helps evade some detection mechanisms because a change to the source code in Axios is going to be more likely to be noticed than maybe just a change in the package declaration. But when people install those packages, they get some remote access Trojan code, and they get info stealer code as well, stealing AWS, Google, GitHub personal access tokens, and credentials that would give the attacker more access to other systems in that compromised organization. We are seeing command and control through lots of different network indicators. We're going to share some more information on this, but we're seeing domain names like SFR, CLAK.com, and a whole bunch of IP addresses and ports and different things like that. But we're seeing this as a multi-platform vector, where depending on whether you install that package on macOS, on Windows, or on Linux systems, you're going to get an Apple script payload, a PowerShell script payload, or a Python payload for your specific platform. The thing that's so interesting about that is that it kind of speaks to automation. And it's hard to say, was this accelerated by AI? But there was some science here which makes us think, maybe, because we're seeing multi-vector attack mechanisms delivered really quickly, crossing multiple platforms. And while that's certainly possible to do for a team of adversaries, it's being done in a really quick period of time. And I think that possibly speaks to AI acceleration too.
Interesting. It is. It's been a whirlwind, and as Josh is mentioning now, right? Make sure you stay tuned, keep up with all the socials, like everything. It's present, as you said, right? Everybody's doing their own incident response right now. We're finding out more information as it develops, so make sure you stay tuned to learn all of those things. And one thing I want to say, I was doing some reading, and I saw a mention of Team PCP, and again, I don't want to state anything or make any claims, but is there anything that we're seeing with Team PCP?
Yeah, so Team PCP is, we believe, an English-speaking threat actor team, and they have connections to Lapsus Group and other English-speaking teams. We know that the Lapsus Group has people in North America, in Europe, and we're seeing some support across teams here. So maybe there's some kind of a informal relationship, or even a formal business relationship between these different threat actor groups. Team PCP is the team that was behind the Trivy supply chain attack, the Light LLM supply chain attack from last week, and we're seeing this as a trend going forward. But some of the indicators are very different here. So the Light LLM attack spoke clearly to this is a threat actor. We're seeing the same kind of indicators as the Trivy team and other GitHub supply package mechanisms, other PyPy compromises for Python packages. And we've seen that pattern from Team PCP, and we're seeing some sophistication here. We're seeing less sophistication in this particular attack, and we're seeing some indicators. Attribution's really hard, and nobody's going out and saying this is DPRK, but some of the indicators so far make us think that this is actually a different team with some of the hallmarks from Team PCP. Now, what often happens with these threat actor teams is that they will succeed, they'll go on a run, they'll get a lot of credentials, they'll get a lot of access, and they're looking to monetize. And one opportunity to monetize is extortion, ransomware. There's a lot of back and forth, there's a lot of effort there, and sometimes the payoff is not always there. But another opportunity is to sell access. So we are posturing here, just trying to guess here, that Team PCP might be selling some of their earlier compromise access to different packages, to different repositories and things like that, to different threat actors like the DPRK. So again, too early to tell. We're not really sure, but we're seeing some indicators here that makes me think that there's some DPRK involvement, but the similarities to Team PCP are so clear too that it makes me think they're bringing in other threat actors, and it could be just a different way to monetize some of the access they've gotten.
Oh, absolutely. And again, as we said, like that's all still ongoing, right? We'll still figure out all those clues and we'll pick all that out as it goes, right? So we won't dig too much on that one. But what I do want to offer now for people that are tuning in and watching, what should they do, right?
Yeah.
You talked about there's so many downloads going on across the board, so many potential people affected. Like, what can organizations start doing to determine, am I involved in this? Like, what does it look like for them?
Yeah, so I wrote up some notes this morning, and I think there's a couple of different perspectives we have to talk about here. The three primary groups that need to be involved are developers, incident response teams, and DevOps engineers, right? So if you're a developer and you have any use of the Axios package in any of your source code repositories, whether it's direct, I'm pulling in Axios, or any of your software dependencies, then you need to check, am I using any of the vulnerable versions? And we know the vulnerable versions are version 1.14.1 and 0.30.4. If you see the package plain-crypto-js anywhere, that is a clear indicator of compromise, because it's only coming from this breach information here. So if you're a developer, one of the things you want to start doing is looking at any of your software packages and looking for Axios in any of your node modules directories or the plain crypto.js package as well. And if you're seeing those, then get your incident response team involved and start looking for other indicators of compromise as well.
Okay.
We see the same kind of thing necessary for developers as well. I think one of the big concerns for me is continuous integration and continuous development teams. If you're doing a nightly build of your software and you're pulling in something like the Axios package or anything that calls that package into your supply chain, then you may have been affected by this if it's within that window of 0 to 100 UTC to about 300 UTC. So we want to be looking at those supply chain issues as well. So if CI/CD packages, if you're doing a smoke build, in the middle of the night or something, or depending on your time zone, we want to look at that as well. For incident response teams, it's not an envious position. This is a tough place to be, because if your developers or your DevOps engineers are saying, hey, we got hit by this, right? You've got a different problem, because now, as soon as that package is pulled in, you're compromised. Okay, you don't have to run anything. There's no extra effort. As soon as you pull in that package, you've got compromise. So now we need to start looking at how do we respond to this as an incident, and we need to start doing things like we need to start verifying, is this really an incident? Is it going to affect us? We need to triage this, and we need to say, okay, where are we taking resources from? How are we going to respond to this? What are the priorities of the organization? And then what we teach in my incident response class is what we call the response actions loop. We need to scope, contain, eradicate, and recover. So we need to say, okay, I see an IOC, an indicator of compromise. Where else is that? Is it anywhere else? Okay, I know the attackers ran code, but what could they have gotten? Did they get GitHub personal access tokens, AWS credentials, Azure keys? Did they get password hashes from the system? The big problem here is that we often don't know what the impact is of a breach like this until everybody's done their incident response. So scoping is the first step. How's it going to affect me? When you see systems that have been affected, like, oh, that ran on a system that has AWS credentials saved. Well, now our whole entire AWS environment needs to be contained as well. And we need to look at that to say, what is my overall exposure? Now, containment doesn't necessarily mean shut it off now, but we certainly have to say, how do we limit the threat actor's access using access control groups, security groups, or things like that to try to limit access. Then we need to try to do root cause analysis. What are the attackers doing with that access, and continuing that loop. Last year at RSAC, I talked about a problem where we're seeing credential sprawl, right, or authorization sprawl, where we're seeing an attacker that gains access, and then once they gain access, they get AWS keys. And once they get AWS keys, they're saying other API keys. And once they get other API keys, now it's personal access tokens to GitHub and things like that, and they're going from system to system to system. Anybody that's gotten hit by this has some long nights ahead of them, and I'm not envious of that job, because it's going to be difficult to figure out what the actual impact is and what that's going to affect for downstream customers.
Oh, it's the life we live in, the world we live in.
It's never boring.
It is never boring, right? And two things I want to get into, and we'll kind of like merge them together here. When we think about this, like, is there a play here where AI assists or helps in anything at all whatsoever there? Like, is there something there for us? Like, can AI be here to help?
As defenders, you're saying? Yeah, as defenders, I think so, right? I think right now, for incident response teams, we are seeing AI adoption mostly on an individual contributor basis. You've got a rock star on the team that bought into Claude Code or Codex or ChatGPT or whatever early on and is able to accelerate a lot of that process. We're seeing a lot of the industry catching up to that as well. So if you're using a tool to be able to track incident response, a lot of times we're seeing AI integration. If you have security information event management or SIM products, we're seeing AI integration there as well. So a lot of opportunity to help accelerate that process. I think the dilemma is we're still far too slow. When threat actors are taking supply chain and within seconds enumerating the environment, capturing keys, extracting those keys, right? We're not going to be that fast. But we have to narrow that window. We can't keep measuring our mean time to respond, how long it takes us to recover this threat, in days or weeks, because that's just too long and too much opportunity for threat actors. I think AI has a role in helping us accelerate this, but I think it's still early days. I think right now it's really individual contributors, but to get more impact, we have to make standards, we have to have people adopting it consistently in organizations, and we need to make sure that commercial vendors are supporting all these initiatives as well.
Absolutely. And I think for everybody that's tuning in for us right now, if you had any, like, not final words, because there's gonna be a lot of words that come out from this from a lot of people to kind of bring everything together, like what would be that last bit of advice you can give to everybody?
Gosh, so, incident response is a hard job, right? It's one of those jobs that is thankless. It's always high pressure. Executives want status reports. Legal team wants to know what their legal obligations are for reporting a lot of this stuff. You've got regulatory commitments, like, are we going to have to do a 10K report on this and things like that. As an incident responder, our jobs are critical. Like, we need to make good decisions. And to do that, we have to take care of ourselves as well, right? You need to make sure you're sufficiently hydrated, right? In a book I've been working on, we've got a little byline that says, a hangry incident response team is not an effective incident response team, right? We need to make sure we're taking care of our people, right? Because there's a lot of hours coming up to people that are going to be affected by this. And it's a marathon, not a sprint. And we need to be in it for the long haul and make sure that we're taking care of ourselves to be effective here too.
Gotcha. Josh, thank you so much for taking your time.
I
know we're busy. I know the whole world isn't really on fire, but there's a lot of people that might feel like it's on fire. Like you said, thankless. A lot of people doing things. Everybody, thank you so much for joining us with this, emergency webinar, webcast, whatever you want to call it. Stay tuned to the blog posts, the SANS social channels. We will provide you as much information as we can as it comes to light. Wishing you all the best in everything you can do. Hopefully we can find, remediation at some point. Again, thank you everybody so much for joining us.